Hey everyone, welcome to a new video in FEA using SolidWorks. So in this video, we'll be learning how to set up a fatigue analysis for a S-hook using SolidWorks simulation module. So before we proceed with the simulation, we'll understand why we are actually doing this simulation. So as you would have seen in any day-to-day application, we have the S-hook in a gold ornament. So we often bend the S-hook that is present in this gold ornament to wear and remove it. So now, since we subject the member to repetitive loads, we are here to study the life and behavior of the part by performing a fatigue analysis on it. So to perform the analysis, I have created a model for the S-hook and let's open it up in a separate window. So here in this model, so in real life, we fix this particular portion of the hook, bend the other section to enable the connecting member to slide into this part. So here this particular portion of the member is bent and rebent to accommodate the connecting member. So we are going to apply the same load here, that is I'm going to fix this region by a constraint, by fixed geometry constraint, and after doing that I'm going to subject this particular portion of the member to a force of 50 newtons and apply a load and predict the life of this part when subjected to 1500 cycles. So let's go back to the presentation. Before we proceed with the fatigue analysis, so let us understand the use of SN curve in a fatigue analysis. So the SN curve for any material gives us the relation between the maximum stress that a material can withstand before failure after subjecting to a number of cycles. So here the stress is plotted in the y-axis and the number of cycles is plotted in the x-axis. So as I mentioned before, we are looking at a SN curve. You can see that the maximum stress value is plotted in the y direction and the number of cycles is plotted in the x direction. Here let's say I have a material and I want to check the maximum stress that it can take after 100 cycles. So I just extend this point here. Note the corresponding value for the maximum stress that can be allowed. Before you proceed with the fatigue analysis, you need to perform a static analysis on the part so that you understand the type of stress that is developed in your part to predict about its fatigue life. So here, SolidWorks provides us with 4 types of loading. The first one is fully reversed, zero based, loading ratio, and then finally the fine cycle peaks. Fully reversed. So as the name suggests, the maximum and minimum load that is being applied upon the material has the same magnitude except for the variation in the direction. Thus, the loading ratio is taken as -1, and if you look at the graph, here you can see we have subjected the material to a maximum load of 1000 and we go for a value of 1000 newtons in the other direction. A very good example would be the gold chain that we are going to analyze in SolidWorks. Here if you apply a 50 newtons to open the S-hook, you then apply a value of another 50 newtons to close the S-hook. This way the magnitude of loading is the same while the direction is reversed. So that is what is meant by fully reversed. Now the zero based. Here after subjecting the material to a maximum value, you remove the load and then reapply the load again. So this way you have the maximum value as the load you applied and the minimum value as 0. Hence the loading ratio is taken as 0, and the graph here shows exactly what the scenario in zero based loading is. A good example for this would be a door knob where you pull the knob with some force, let's say it's about 100 newtons. So and then close the door, thus removing the load on the door knob. Again you apply a force and this continues. So this is what zero based loading condition looks like. Now the other type of loading that you can give in SolidWorks is using loading ratio. Here you have a ratio between the maximum and the minimum load that is applied. So once you give the maximum load and input the loading ratio, the software automatically detects the minimum value and then proceeds with the simulation. The graph may look something like this, where you can see the maximum value is something here and the minimum value is not exactly the same in the opposite direction, but it's just offsetted a little bit down. So there is a loading ratio of some value between -1 to +1. Finally we have fine cycle peaks. Here SolidWorks provides an option to import the stress values from the various simulation that you have already carried out on the part using SolidWorks simulation module. So now let's look at the results that can be inferred from a fatigue analysis. The two types of results that one can request from a fatigue analysis would be damage and the life. First, the damage. From this particular result, we can understand the percentage damage done to the material by exposing the same to a given number of cycles. This value varies from 0 to 100 depending upon the damage cost. Next, we have the life. This life is defined in cycles, that is the number of cycles the part or the material can withstand before experiencing any failure. You will understand this in a better way when we proceed with the simulation. So let's proceed with the simulation. So to do that, import the model in SolidWorks and then zoom, pan and rotate the geometry to check if the model is perfect. So once you do that, click on the new study here. And before you proceed to perform a fatigue analysis, click on a static analysis. Since the variation of the stress can be studied only on a static analysis, using the result from the static analysis, we can proceed to perform a fatigue analysis. Now right click on the S hook and click on apply material. Choose other materials and select pure gold. Click apply. Once you do that, right click on the fixtures, click the fixed geometry. And as we have discussed previously, select these two faces and fix them. Now right click on the loads, create a force on this particular face for a value of 50 newtons and click OK. Let's use the default mesh and run the simulation. We can see we have obtained the results instantaneously. Just animate and look at the application of the loads. Now that we have completed the static analysis, let's proceed with the fatigue analysis. So click on new study and select fatigue. Here you will be asked whether you want a constant amplitude events with defined cycles or variable amplitude, harmonic fatigue or random vibration. So we'll be doing only fatigue analysis due to constant amplitude and click OK. Here right click on the fatigue and click on the properties. From the properties of the simulation, you can select the different settings depending upon your requirements. So you have been given different failure theories which can be chosen to obtain the results, and right now we are not going to change anything, so click cancel. Right click on the loading and click add event. Here since we are going to apply a fully reversed kind of load, make sure you have a fully reversed option here selected here. I'm going to check if this part will sustain 1500 cycles for a given load and click OK. Once we do this, we are all set to proceed with the simulation, but we haven't yet defined the SN curve for this simulation. So right click apply or edit fatigue data. We have an option to derive from the material elastic modulus. Select that and we have a table that is populated here. Click view to plot data in the SN curve. Here you have the number of cycles. This is the maximum stress that is allowed and click apply. We are now good to run the simulation. Let's run the simulation here, and we have got the damage as well as the results in life. Before we could infer anything, right click on the legends, click chart options and change the scientific notation to floating. Click OK. Now for the results, right click show. Similarly right click, do chart options and change it to floating. Click OK. So first let's have a look at the damage. Here you can see the portion that is colored by red. There has been maximum damage percentage of 200, while on the other side of the bending we have a maximum damage of 50%. Let's look at the life now. We wanted to check if this particular part will sustain for 1500 cycles, but since most of the portion which is colored red is going to fail within 746 cycles, this particular part will not sustain 1500 cycles without any failure. So we need to either change the material or improve the design by adding some more thickness to the part. So now we have successfully completed a fatigue analysis on this S hook. Try this simulation again and you will be provided a challenge to work on. Thank you guys for watching, and I'll see you guys in the next video. Bye.